So this will be a full guide on how to use a MongoDB Realm as a local database in your Android application. I'm going to cover almost everything you need to know so that you can get started as quickly as possible. And I know that the most popular library at this moment for a local database in Android is a Room, but after watching this video you might want to consider switching from a Room to a MongoDB because working with Realm feels so easy. And before we dive deeper into the code itself and I introduce you with some important concepts, let me show you the sample application that we are going to build in this video. So this application will contain the logic for a basic CRUD operations like reading, inserting, updating, deleting, but also querying and filtering the data from a MongoDB Realm as well. So on the top here we have two different text fields. The first one is used for the object ID, which represents the unique identifier for each and every document inside this collection. And the second one represents the name of each and every person inside this collection. And below those two text fields we have 4 different buttons, and each button will trigger a different logic. The first one will basically insert a new item or a new person in our collection. The second one will update the existing person name. The third one will delete a selected person from this collection. And the fourth one will basically use this name text field to filter our result here to display only those queries or names that we are searching for. So first let me show you here actually how to add a new element inside this list. So the last one here is this one, and now I'm going to add here a new name. For example, let's add here a random, and let's press add. So after we press add, a new element here will be added to this list, and this element will also contain this unique identifier, which is called an object ID. Now of course we can also update this same person object, so let's just copy this actual object ID. So by using that same object ID, we can find that document inside our collection and we can update its name value. So for example, here I'm going to write now new random, and now let's press update. As you can see, now we have successfully updated that person document inside this collection. And of course we can use that same object ID to find that same document and even delete that as well. So let's now press the delete button, and as you can see we have deleted that same document with that same object ID. Now there is also the last logic that I have implemented here, which is called filter, and with the filter we can basically just filter one of those documents with a name that we have specified right here. So let's here for example type this first one and press filter. As you can see now we will be able to filter only that document with that same name or the query that we have written here in this text field. We can also just type one letter, for example A, and then we will be able to filter all different documents that contain that same letter. In this case, as you can see, there are many of them. And there you go. So that's basically how this sample application will look like. Now, before we dive deep into the code, let me show you the sponsor of this video, which is me. So I have just released a new course about a multi-modular architecture in Android, and if you wish to learn how to fully develop an Android application that will be able to automatically synchronize the data from the local database with a MongoDB Atlas in the cloud by using the device sync service, then I highly suggest you to take a look at this course, and the link will be down in the video description. So what is a MongoDB, how does it work, and why it is so popular among developers? MongoDB is a document-oriented database, which means that the data inside a MongoDB is stored in a form of a JSON-like documents. If we imagine MongoDB Realm as a hierarchy, on the top there will be a database which would contain multiple collections, where each collection contains documents and each document contains multiple fields. So collections are similar to the tables that we have in our relational databases, and the documents are something like records or rows inside the tables. Now, some of the key features of a MongoDB Realm are high performance, so a MongoDB supports indexing for a faster search functionality, then the aggregation queries can help us in a faster processing, and querying is also quicker because related data are stored together in the documents and not in separate tables like we have in our relational databases. The next key feature is scalability. So MongoDB is a specialized database for big data processing. It can contain large volumes of data, therefore making it highly scalable. MongoDB supports a data encryption, then in-memory storage engine. Also, implementing relations and using migrations feel a lot simpler with MongoDB Realm as well. And the Realm is also a popular choice for multi-platform projects, since it has a lot of different SDKs for many different programming languages, including Kotlin. MongoDB supports various different data types like string, integer, double, boolean, char, short, long, float, double, byte. Then there is a RealmInstant, which represents basically a data type that holds the values and information about the date and the time. Then we can also store regular objects. We can store a realm list or a realm set. Those two are used to store too many relations in our database. Then we have a realm UID, which is used for uniquely identifier informations. Then we have a backlinks delegate and a mutable realm int as well. Okay, so those were some basic information about the MongoDB, and now I'm going to briefly introduce you with this project itself and show you what kind of dependencies you are going to need for a MongoDB Realm. So there are only two dependencies that you're going to need, in this case Kotlin coroutines core and a Realm Kotlin library base as well. Here in this project I also have a dir-hilt library because I'm going to use that dependency injection library to make my life a lot easier. And here I have just one dsugar JDK library which will allow me to specify the minimum SDK to be 24 and not 26 because of one part of this code that I have added in this project, and you will see about that. So those are all dependencies that here I have in this project, and of course the plugins for a dir-hilt library, for a Kotlin cap, and the IO Realm Kotlin as well. Now in our other different Gradle build file, in a project level Gradle build file, we also have plugins for a dir-hilt library and for a Realm Kotlin as well. Now when it comes to the project itself, as you can see, I have specified here and set up the dir-hilt library. So I have created this application class, I have annotated our main activity with this Android entry point annotation as well, so everything here is fine. And our main activity will contain only one screen, which will be a home screen, and that home screen will contain all those elements that we can see right here. Now our actual home screen will not contain any state, so all different states will be hoisted outside of this home screen, and that will make our home screen a lot easier to test later. So as you can see, our home screen is actually a stateless component or a stateless composable function. It contains a scaffold which contains this home content, and this home content of course just displays those actual UI elements like those two text fields that actually receive this object ID and the name as a value of those two text fields. Down below we have those 4 different buttons, and each button will trigger a different lambda, so on insert clicked, update, delete, and filter clicked as well. And at the end we have a lazy column which just displays all those information from our Mongo Realm database as well. And this person view is just parsing those actual information from our database into those text elements that we can see right here. So the first one is a name, the second one is the actual object ID, and this third one is just for displaying that timestamp as well. So basically here I have prepared the full complete project, and I'm not going to waste your time by typing the code. Instead, I'm going to go through each and every file here step by step and explain you how to successfully set up the MongoDB Realm in your application. So that's how our home screen will basically look like. So it will have all those states passed from outside of this actual screen, and those lambdas will be triggered from the outside as well. So as you can see, this home screen will just use those lambdas to trigger certain functionalities that we're going to store in our view model, as with all other different values as well. Now, when you are starting with MongoDB Realm, the first thing that you need to do, you need to handle the creation of an object model. So in this case, our model is called person. So let me just open that Kotlin file right here. So that's the first thing that you need to do when you are working with MongoDB Realm. And each one of those classes that we have right here will represent a separate collection in our MongoDB Realm database. So when you're creating those object models, you need to make sure that you implement this Realm object interface, right? And that's how you can mark your actual class as a collection in a Realm database. Now, one thing to point out here is that at the moment of recording this video, a Realm Kotlin SDK does not support the actual data classes, which is why we need to use those regular classes and define those properties within the body of those classes as well. So if you want to mark your actual class to be a collection within your Realm database, then you just need to implement this interface, which is called a Realm object. Now, inside this first person class, you can see that I have defined not just the regular properties, but also a relations with other different collections in our database as well. So the first property here is called the ID, and each and every property here will contain a var instead of the val. So that's the rule you need to follow if you want to use this Realm Kotlin SDK. So you do need to define those properties in the body of that class. Now this first one, as you can see, have a type of object ID. So object ID is a special type in a Realm database, which represents a unique ID of each and every document inside the collection. And by using this object ID.invoke, we are able to create and basically specify a default value of this ID property. So whenever we create a person object, then this ID will be automatically generated by invoking this object ID function, which will generate a unique ID for each and every document in our collection. Now, each and every unique identifier for a document needs to have a primary key annotation as well. Then down below we have just a simple property name, which contains a default value of an empty string. Then we have this age property, which contains a type of an integer value, and here I have specified a default value to be an 18. Now here we also have one interesting annotation called the index, and this index annotation is basically used to optimize or speed up the querying of that annotated field inside our database. So primary key is also marked with this same annotation, which means that you don't have to specify that annotation twice when you're declaring a primary key. So without this index annotation, a Realm database must perform a collection scan, or basically scan each and every document inside the collection to select those documents that actually match the query. But with this index annotation, we are making this process a lot faster. So basically we are marking our properties inside our collection with this index annotation if we are planning to query our document a lot by using that same property as well. So in this case we actually don't need this index on our age property, but I have specified that property just to explain you what it is. Anyhow, let's just continue. So the second or the next parameter here or property is called adult, and we have marked this adult property with this ignore annotation. So by specifying this ignore annotation on one of those properties, it will mean that we are basically going to ignore this property and we are not going to store that property inside our collection or our database. Then the second property here is address, which is basically a whole new object model that we have defined right here. And this is what we call a relation, okay? So we are relating our person object with an address object, and we are specifying its default value to be null, which means that this actual property will be optional, so it's not required. We don't have to pass this address property when we are creating our person object, and if we don't pass this address, then a default value here will be used instead. Now this relation here is called the to-one relation, because here we are relating this person object with only one address object, and down below we have a to-many relation, which basically relates our person object with multiple different Realm objects, okay? So in this case, for too many relations, we are using a Realm list type, but there is also one more type which is called a Realm set. So those two are similar. Anyhow, here as a default value I'm specifying basically an empty list of those pet objects, and this property right here represents too many relations, while this first one represents to-one relations. And of course at the end we have one property which is called a timestamp, and here we are using this RealmInstant type, which is basically a specific type that is used within the Realm database to store a date and a time value. And here I'm using a default value a RealmInstant now, which will basically give us the current date and time when we are creating a new person object. And of course those other different two collections or model objects contain some regular or primitive types like the string and integer value as well. Okay, so now that I have introduced you with the actual model class or our collection that we're going to store in our Realm database, now we need to proceed and actually configure our Realm instant before we can work with our Realm database. And to do that, we need to open up our database module. So before we can interact with our actual Realm database, we need to configure and basically provide a singleton for our Realm instant. Because later I'm going to use this same Realm type to inject into our repository where we can interact with our database. So in this case, as you can see, this function just basically returns this Realm, which is a type that we're providing with this function. And here we are, of course, configuring our actual Realm. The most important thing here to note is that inside this builder, you need to provide a schema, and that schema needs to contain all those object models that we have just created, so person, address, and pet. And of course here we just need to call a build function, but I have also called here one more function named complete onLaunch. So to keep things short, this complete onLaunch function will allow us to optimize the size of our Realm database whenever we launch our application. And here I have just commented out one function which can also allow us to specify the initial data and pre-populate our database the first time we launch our application. And after all of that, we just need to call here a Realm and its open function and pass this configuration to that function. And that's how we will be able to create a singleton for our Realm that we can later inject in our Mongo repository and interact with our actual Realm database as well. Down below, as you can see here, I have specified one more function which will allow us to provide our actual Mongo repository, and that Mongo repository actually depends on that same Realm that we have described how to provide right here. Okay, and now that I have shown you how to actually describe and configure this Realm object, now I'm going to open up the actual Mongo repository and show you the actual code that I'm using to interact with the Realm database itself. So first, let me show you the actual interface that we're going to implement along with its functions. So this interface contains 5 different functions. The first 2 will be used to actually read our database. So the first one will just get the whole list of our person documents from our collection. The second one, filter data, which will be used to actually filter our Realm database and get only those documents that actually match the query which we're going to write. Then we have here an insert person function, which will basically insert a new person document inside our collection. We have an update person, which will also just update one of those existing documents in our collection, and delete person, which will also just delete one of those documents from our collection. Now let's open up this actual implementation of this repository so we can see how those functions actually look like. So here you can see that we are actually using a Realm as a dependency of this actual Mongo repository implementation, and we have specified that dependency right here in our actual database module. So as you can see, this first function, we are using that same Realm and calling this query function to query our Realm database or this actual person collection and retrieve the result as a flow, right? So we are retrieving all the data from our actual Realm database, and we are mapping all that data as a list. So the same type that we can see right here. The next function, as you can see, takes one parameter, which is the name of our person. And we are also using this query function to query our person collection. Only this time we are writing a manual query that will be used to query our Realm database. So here we are just querying all documents that contain the name field similar to the one that we are passing here as a parameter. So here this contains is actually a word that is used as a query, and this a C character will mean basically that we are searching or querying all different names that actually are either capital letter or lowercase letter, so it doesn't matter. And this dollar symbol and this 0 represents the first parameter in this var arg parameter of this query function. Of course, we can also write some more queries here, and for each query we can write here a different parameter, for example a dollar symbol, then a 1, and then this one will refer to the second parameter that we passed to this var arg parameter as well. And of course we are getting that result as a flow and mapping that into a list. Then we have here insert person function, which uses this same Realm instance, but this time we are calling a write function to actually write to our Realm database. So to actually create a new document in our collection, we just need to call here a copy to Realm function and pass that same object. The next one is update person function, which also calls this write function. And within this block, we are first writing the query to find that specific document with that same ID that our person has that we are passing to this function. And we are getting the first result from this query. And on that result, we are changing the name value or the name field to that new property that we are passing to this function. And the last function here is for deleting our actual person document from our collection. So we are also first querying that person that we are actually passing here as a parameter to actually see whether we can find that person or not. So if that person document actually exists, only then we can call this delete function, okay? And the reason why here I'm calling this a try and catch block is because this delete function can actually throw an exception. And that's why we need to here handle that case. So if we receive some exception, then we can just, for the demonstration purposes, just log a simple message here. And if everything is fine, then we are just deleting that same person document from our collection. So that's how our implementation here actually looks like. Now let's open up our HomeVieWModel to see how we have implemented those functions here as well. So our HomeVieWModel contains a couple of different properties that we are using in our application. So we have a name, we have an object ID, and we have the data. So those first two properties are used for those two first text fields. And whenever we type something inside those two text fields, then we are triggering those two functions to update the actual object ID and the name property in our ViewModel. And those values are passed directly to this home screen, okay? So name and the object ID. Next thing here, as you can see, as soon as we initialize this ViewModel, which will be as soon as we actually launch our home screen, then we are immediately fetching all the data and updating this data property from our HomeVieWModel. And this data property is observed from our main activity and passed directly to our home screen, where we are displaying all those information to our screen. Then down below we can also see some different functions like this insert function. So we are of course calling those scopes to launch the coroutine, because this function is actually a suspend function. And the first thing here, we are checking whether this name field or text field is actually not empty. So only if we have typed something inside that text field, only then we can call this insert person function and try to insert a new document in our collection. Now here as a parameter, I'm passing this person object and I'm applying only one property, which is the name. So even though this person object actually contains multiple different properties, for the demonstration purposes, I'm just focusing on this name property and not on all other different properties that you can see right here, okay? Because this is the project for the demonstration purposes. And I'm also just basically updating the name of this document from our Realm database, and all other different properties will use those default values that we can see right here. And this object ID will automatically generate a new ID whenever we pass this person object to this function. Then here we have an update person function, which basically checks whether this object ID text field is not empty. So only if we have written some object ID within this actual field, only then we can use that same object ID and pass that inside this person object. So as you can see in this case, I am converting this object ID string into a regular object ID type by specifying this hex string as a parameter. Then next here down below we have a delete person function, and the first thing which we are doing here, we are also checking whether this object ID text field is not empty, and only if we have some object ID, then we can use that same ID to delete that same person. And finally, the filter data function is basically used to either populate our data property with either filter data or with either all data that we are fetching from our database, depending on which value here we have for our filtered value. And there you go. So that's basically how the logic of our application looks like. And now at the end, I'm going to show you how to use one very useful tool called Realm Studio, which will allow us to basically view our actual database that we have in our application. So here first, I'm going to open up this device file explorer. I'm going to launch this Android emulator once again, and then I'm going to find that a Realm database file, and I'm going to export that same file so that I can inspect it and see what kind of data we actually have in that database. I'm going to also just show you one website, so the official MongoDB website, where you can find the Realm Studio tool. And this Studio is a visual tool to view, edit, and design a Realm database file. So we can query object in a database, we can view live objects, we can create, modify, and delete objects, we can add classes and properties to the schema, we can export the schema, and save and import changes into a client application or a production database as well. So I have already downloaded this actual tool, but if you haven't, be sure to check out this actual page and download this tool on your machine. So I'm going to now launch this Realm Studio. There we go. So I have already installed this application. Okay, so now before I open the Realm file, I need to export that Realm file on my desktop. So here I'm browsing the file explorer of this actual Android emulator. So let's just here open up the data package, then a data package as well. And down below I'm going to search for the package of this same project. So let me just go down below. So a Mongo demo, there you go. Here I'm going to open up the files, and there you go. So this is our Realm file. We can also select all those 3 files, there you go. And now let's right click, save to, and I'm going to save them on my desktop. So let's just go right here, let's find a desktop, click OK. And now we are exporting all those Realm files of our actual database that we have in our Android emulator. So I'm going to now open up that Realm file. There you go. So we have exported that file successfully. Now let's press open. There you go. And here we should be able to see all those same information that we can see in our application as well. So we have a couple of different person documents inside our person collection. As you can see, we can see the actual ID property. We can see the name, the age, the address, pets, and the timestamp as well. So this first ID is automatically generated whenever we create a new person object. Those names we have modified by ourselves. This age property is also generated by default. Then we have this address object, which is a null by default, so you can also pass a whole separate address object if you want to have some different value by yourself. And here we also have a to-many relation. In this case, we are just generating an empty list for this field in our document, but of course you can pass the actual value by yourself. And the last one is the timestamp or the date, which is actually a RealmInstant type, which will give us the exact value of the date and the current time as well. And there you go. So that's how you can easily observe and visualize your actual data that you have created within your Android application. And from here, of course, you have an option to either create a new or delete one of those existing documents as well. So if I go right click here, then you can see options that says create new person, and we can create here a new person document, or we can select one of those existing documents and press right click to delete that object from our collection as well. So this is a very useful tool if you want to visualize your actual Realm database that you have created within your Android emulator. And that's pretty much it, okay? So now I have showcased all different kind of operations and queries that you can use with a Realm database. So you have seen how easy it is to actually create the Realm database and interact with that same database in your Android application. So we have provided that Realm instance and we are using that same instance to interact with our database by calling this query function or this write function. And also it's very easy to define your own object model and specify all different kind of types that you're going to need for your application. Now be sure to comment down below and let me know what you think about this MongoDB Realm as a local database for your Android applications. And also be sure to like this video, but only if you find it helpful. For this video, that will be all.